What's up everyone? Continuing from the next series in our product introduction, we have our Agam GNSS products, which are CAN based, and currently we offer two different products which can be differentiated by the RTK marking and without RTK, and also you can see the diffuser being white here, and here the diffusers are translucent. So what this difference here is, so the first version being GNSS 01 is based on M9N module from uBlocks, Neo M9N, and this offers a single band which is L1, and along with it the sensors set, which are IMU, barometers, magnetometer, and then there is a buzzer, and then the status LEDs, and then a safety switch. All of these are combined into a CAN protocol, and there are two CAN connectors here where you can actually plug into let's say to the autopilot, and the other one can be connected or daisy chained to any other CAN devices. And the other part is going to be the GNSS 02. Here you can see that it's based on uBlocks module again, but this is based on Neo F9P, which offers L1, L5 band. So here you'll be able to do like more number of satellites because there is more support on the number of bands here. And at the same time, this also supports the Indian NAVIC, wherein you'll be able to get the Indian constellation, IRNSS, along with like a lot of other bands. So you can go through our data sheet or the tech specifications which are there in our website, as well as like our documentation. And here, along with the new F9P, you get like the similar features. Both are CAN based, and as I said, like there is IMU, barometer, magnetometer, and then there is a buzzer, safety switch, and the status LEDs here. All of these are communicating through CAN protocol to the autopilot. Very similar to what we did in our previous video, which was Agam fluorine sensor, same CAN protocol, but here it's different sensors. So this is based on GPS and optical flow sensor, and rangefinder is available on the fluorine sensor. So coming to the setup, like you can choose any of these based on your requirements. You can let's say like you want a price sensitive product, which is like going to be our Neo M9N. And if you want like NAVIC support, and at the same time Neo F9P also provides you the RTK features. So let's say like you want to get connect to an RTK base, which we also have been working on. In the next episode, we'll be looking into the setup of RTK features and functionality. We'll talk about more on the RTK functionalities in the next episode. Here we'll just set it up as a regular GPS or GNSS module, and we'll be able to like configure and get the satellite positions, and we'll do a demonstration of the entire drone. There we'll be able to understand how the GPS and what are the features and functionality it offers. So now let's look into the mounting of the GNSS. So we have our own mount here, which is again machined and assembled in India. So I've already attached the mount over here. So I'll just stick the GNSS module, and I have the CAN cable coming out of the CAN port from the autopilot side. As you can see here, we have the one CAN wire going into the flow range, and the other coming out to the GPS. So it's already, again, as mentioned in the documentation, the wire needs to be twisted to eliminate a lot of the noise and interference. It's already twisted, so I'll just wound it around the mount, and I'll just plug in the GPS port. As you can see, also it's plugged in, so do not connect in this way. Again, we need to reboot it, but I'll just show you the settings which needs to be done, so we'll be able to reboot once again. UV can enable. As you can see here, it needs to be set to sensor automatic config. Here you'll be able to get all the nodes assigned to the CAN devices automatically by the system. So you can do this, click save, go to tools, reboot. So let's wait for it, and it should be able to boot up. And as you can see, there is a 3 flash. I'm sure you could have heard the buzzer noise. The startup
Pre-flight, GPS fixed too low.
We got that connected.
Pre-flight
and as you
fail.
can see here,
Compass 1
it's
uncalibrated.
able to detect the compass compass 1 uncalibrated, so that's good. And you're also able to see the GPS data here. It shows like the number of satellites, log, HDOC, VDOC. Right now we are indoors, we'll not be getting anything much, so we'll go out and test it. So before that, I wanted to show you some of the parameters. For GPS to work, it's just the UAV can enable parameter that needs to be set. But once you do that, and if you search UAV can, you can see the more number of parameters showing up, which is something we have already seen with our optical flow and rangefinder, which is Agam flow range sensor. So once this is enabled, it also gives you few parameters for your GNSS product. So one is like, you can search for UAV can and sub, wherein it automatically enables the mag here, and the GPS is also enabled. And as seen in the previous video, we have already enabled flow and rangefinder. So this is something you need to make sure it's enabled, but by default it's always enabled. So for GNSS to work right out of the bat, it's just you need to enable the UAV can parameter and it should work. And let's say like you want to like have some of the GPS features on the EKF algorithm. So let's go to EKF2 GPS control. So here, if you want to like have all these features, you can set this to make sure like it's set to enable all these if you want to. And let's say like you want to do dual antenna, like wherein you want to like daisy chain and have like 2 antennas for heading, you'll be able to do that as well here. And you can have these also enabled, so that's not a problem. So this is something you need to make sure. And also in our case, it's more closer to the center and maybe the height is bit offset. If you need to really give offset, let's say like your GPS on a very big or very large drones, your GPS is way offset from the center of gravity of your autopilot or flight controller, then you need to set that offset in your system, the same way we have done with optical flow sensor. So here you need to just search for EKF2 GPS, and then you get the position X, Y, and Z. So this is all in meters, so you just need to measure what is the offset you have given and then enter that value. For now, I think the position, if you are able to notice it, like the GPS is probably like 10 centimeter off from the autopilot. So we can just enter 0.1. In most cases, it will be able to compensate when you do the calibration, but it's good to have that offset. All right. So once this is done, you can go through the compass calibration, or you can also do the PX4's compass dance, wherein like as the drone is powered and it's not armed, the drone is always going into a calibration mode. So you can actually carry the drone towards the field, and let's say like it's plugged in and you want to have the compass in that process, you can save some time, and like as you carry the drone, you can just rotate it if it's a small drone. If it's a large drone, probably like few more people needs to be there to carry it and like spin it around. So you can do that, or you can do the compass calibration in the field where there is like much less noise. As you can see here, there are more interference, and like it could cause like bit of a interference and like bias towards the sensor's calibration. So we'll just do that in the field, and you'll be able to see that in the system. What is showing up as like compass 1 uncalibrated, you will be able to see that it'll get disappeared, so that like it is ready for flight. And now you can see that it says like not ready. So let's go to the field and do a compass calibration and do a flight test. And in the flight test, let's do 2 videos wherein like we'll be flying with the GPS and flow range. And one, I also want to like demonstrate just without GPS and only the flow range sensor. So you will get an idea of like how good the flow range sensor is in its capability of position holding. Even without GPS, you can actually do a position holding. So we'll look both of those things. All right, I was able to set the drone up, and I was able to connect all the propellers, and it's plugged in. And you can see one thing I wanted to also mention is that GNSS direction here. As you can see, the visual identification is to keep the GNSS pointed forward,
the same as the Agam Autopilot. One is your logo, both the logos pointing forward, and if you're far from it and you're not able to see the logo, visually you can actually see the GNSS is pointed in the forward direction, and you'll be able to notice it if it is like, you know, rotated the other way around or something. And now let's get started with the flight. And as you can see over, it's a bit cloudy, and let's check the GNSS count. I just plugged in, so we'll just be able to notice it. As you can see, GPS count is 30, and it has a GPS lock, 3D lock, with H-drop and V-drop being 0.5 and 0.8. Technically, H-drop should be less than 1 and V-drop should be less than 1.5, which is good here. And we got like 32 max satellites of, it's a max satellites from the PX4 or Autopilot firmware side. But if you connect this to u-blox, you'll be seeing like more number of satellites than this, like which can be like increased if needed. But 32 satellites is way more for most of the applications. And we also got like 3D DGPS lock, the differential GPS. That's great. So let's get a flight for now, and let's see like how it goes. So right now it has both optical flow sensor and GPS, as I said. And in the previous video, we were able to see that I have set the arm switch over here, and this is the kill switch. And these are the different modes. So I have put to the position mode, as you can see on the display. Yeah. So it says position, which is good. And we also have the power module, which is showing 54% battery. So let's arm it and then fly the drone with optical flow sensor and the GPS. You can notice it's holding the position, but it's been like really windy today, and it's been windy for a very long time. So you can actually notice that it still be able to hold the position. I'll just let it stay there, and I'm not giving any kind of drone corrections. I'll just hold the radio as well so you can notice it. And probably I can show you it's the same radio if I'm increasing the throttle. You can really see it's like pretty windy today. Alright, as you can see here, we just disconnected the GNSS on top, and the cable is not connected to anything, it's just disconnected. And right now it's set up only for the flow range sensor, which is like optical flow and range finder. So we will do a demonstration of the sensor's capability in position holding without GPS. So this is basically, you can call it GPS denied. But as we discussed, the flow sensor and the rangefinder has its own limitations in the height and altitude. It can work about 30 to 50 meters in a good range, and probably at max of 100 meters if the environmental conditions are really great. So now let's test it out, and I'll show you like, you know, how it's going to position hold without GPS and just flow range sensor. I have plugged in the battery, and let's get started. Alright, and if you notice, like I'm still on the position hold mode, and should be able to load it. And you can notice here no GPS data, right? Like with GPS we saw all this information flooded with the count, GPS lock, H-drop, V-drop, so there's nothing here. And you can also notice we are in still a position mode. let me focus it. Yeah. Right. So I'm still in position mode. I'm just showing it once again. Okay. I'll just arm the drone and it's spinning. And as you can notice, I'm not holding the radio stick or controlling it. You can literally see the drone holding the position. I'll just show you the data once again. No GPS, still in position, and you can notice the drone is pretty stable even though there is like a good amount of wind. So as you can notice, like I'm not giving any kind of command, and I'll just leave it here. You should be able to see like the drone holding its position. And one thing to note here is, compared to GPS, this is not doing the waypoint navigation or anything. It doesn't know the global positioning, right? That's what GPS is. GNSS is for, based on the satellite, it knows and records its position. So flow range sensor is more for a localized positioning. So if I'm, like right now it's staying here, so it knows this is the position and tries to hold it based on the optical flow sensor's image and the rangefinder's height. So now if I change it, let's say like I go forward and a bit more higher, so it will be able to hold it based on that current position. So now it lost the previous data, so it doesn't know anything about the history of all its waypoints. So the battery went a bit lower. So for now, I think you got the idea of the flow range sensors capability and GPS. So GPS is good in terms of, let's say you want to do waypoint navigation and like much higher altitude and so on. That's where it's needed. And flow range is really good in the first initial positions of takeoff and landing positions, or in the intermediate positions wherein like it's closer to the ground. I would say like 30 to 50 meters, and at max of 100. Combination of solutions you need to add, and flow range sensor is a great option to combine with the GPS, wherein like you'll be able to get all the GNSS satellites and also like optical flow sensors and rangefinders capability. And let's say like you are flying in a environment where you're going to have your GNSS spoofed or jammed, so you need to have some kind of a localized positioning, so that's where it will be helpful. Or you have applications where the drones are going outdoors to indoors, and the moment you come indoors, you're just going to lose your satellite data. So that's where I would say like the flow range sensor is going to be like a very great advantage to hold its position and not worry about losing the GNSS satellites. Both are complementary to each other, and both products combined is a really great solution. Alright, thanks for watching. See you in the next video about the RTK and other products. Thank you.